So here we're going to look at some of the circle theorems we need to know. In particular, we're going to look at isosceles triangles and circles, we're going to look at tangents to circles, and we're going to look at right angle triangles in circles in kind of assorted ways. And so what we're going to do is just cram all of these into one video, and we'll stick an example or examples at each thing, and we can pause it as we go through. Okay, but for easiness sake, we're just going to bundle them all together and we can work through them then at our own pace. So, the first one, let's look at isosceles triangles in circles. So, before we get started, we need to remember some terminology about the circle. So, we've got our circle here with the wee centre in the middle. If we draw a line here, we've got a chord, which is a line that cuts through the circle but does not go through the centre. Okay, so if we were to draw a line that goes from one side of the circle to the other through the middle, that would be a diameter. Okay, but if it just cuts the circle here, then it's a chord. If we draw a line like that, from the centre of the circle straight out to the edge, or from the edge straight into the centre, then we've got a radius. Okay, and if we were to do that from either end of our chord here, then what we've got is we've got an isosceles triangle. Okay, we've got an isosceles triangle because the two slanty lines at either end, if you like, are both radii. Okay, they've both gone from the middle of the circle straight out to the edge, and so they have to have the same length. As a result, that means the two angles are equal that we've created at the chord. Okay, so whatever angle it is on the left-hand side, it has to be exactly the same on the right-hand side. So, as an example, what we might want to do is we might want to find the missing angles in this triangle. Okay, so we've got a chord, we've got two radii, and so straight away we know that we've got an isosceles triangle. So without having to put very much thought into it, we know that that angle at the other end also has to be 50 degrees. What have we got so far? Well, we've got 100 degrees so far in my triangle. There needs to be 180, so take away our 100 from 180, means my missing angle there needs to be 80 degrees. As another one, if that was 120 degrees, well, we know that we've got 60 degrees left to find somewhere in the triangle, and because it's isosceles, those two angles have to be the same, and so 60 divided by 2 means each of them are 30 degrees. Okay, so the next thing we'll look at are tangents to circles. So a tangent is a line that meets the edge of the circle from the outside only once. So if we've got a circle, and we draw on a line like that, it touches only once, right at the very bottom there. That is a tangent. And if we were to draw a radius from the centre to the tangent, that creates a right angle. Okay. So what we might want to do is we might want to use that fact to help us find the missing angle. And so if we were to take this circle, we would have drawn a tangent there, and then join it up to the centre to create a bit of a triangle. We might give you that angle, or we might ask you to find the missing angle at the top. Okay, well, we can do that because we know the one in the bottom right has to be a right angle. Okay, because that's where the radius meets the tangent. Okay, and so whenever that happens, we create a right angle, and because of that, we know that we've got 140 degrees altogether, so the missing angle at the top needs to be 40 degrees. Okay, 50 plus 90 is 140, plus another 40 gets me to 180. Okay, we might want to find some right angle triangles in the circle. Okay, so that one kind of involved some stuff on the outside, but there are a couple of places where they happen inside the circles. So, if we were to draw a diameter through the circle, and we joined either end up to the same point on the edge of the circle, we create a right angle triangle. Okay, so we had our diameter, and from either end of the diameter we joined it up to the same point on the circumference. It creates a right angle. Okay, doesn't matter what way it looks like it's going. So if we've got a diameter, we pick the same point in the circumference, we create a right angle at that point. So How can we use this? Well, we might want to use it to find the missing angle. So again, we've got our diameter, and we're joining them up to the same point at the edge of the circle. It creates a right angle triangle. So if that angle at the top is 20 degrees, we know that one down the bottom is 90 degrees. And so that means my other angle there has to be 70 degrees. Okay, so by combining some of these things, we can make another right angle triangle in the circle. And so if we've got a circle and we've got our center marked on it clearly, we can draw on a chord. What we can do is we can extend the radius from the center down to one end of it. And if we draw another line from the center, now just straight down to the chord, it creates a right angle where they meet. Okay, and as a result, we've created a right angle triangle. Okay, so when we're looking at these ones, we often refer to them as the tunnel problem. Okay, they inevitably involve some kind of situation involving a tunnel. All right, so let's look at an example. A tunnel, funnily enough, has a radius of 8 meters and a floor length of 14 meters. Find the height of the tunnel. Here's our picture to go with it. And so we often refer to it as a tunnel mainly because when you're boring a tunnel, you've got to bore it as a circle. But if you were to try and drive along that, or you try and put your train through it, that's not going to work. And so we've got to put a kind of flat floor in the middle of it, down towards the bottom of it, so that they can go along it. And so if we were to imagine that's like a train tunnel, okay, the train tracks would go along that horizontal line. That's kind of the idea. Anyway, what we want to do is we want to find the total height of that tunnel. So we want to find that bit there from the horizontal line straight up to the top. Now, fortunately, we already know some of that line. Okay, we already know that from that line marked on up to the top has to be 8 meters because that's from the center out to the edge of the circle, and so that line there has to be a radius. Okay, so we know that bit at the top there has to be 8 meters. What we don't know is that bit at the bottom. Okay, now one of the things that normally happens with these pictures is that they are notoriously not done to scale, and so we've deliberately done that here as well, partly just to make you realise you're going to have to actually sit and work it out, and partly because it's easier to draw that way, which is why they don't do it. Okay, so what we can do is we can think about that little triangle section down the bottom because we've created a right angle, and so we're going to think about it as a right angle triangle. Okay, now whilst we can do a lot of things with the angles, and we have been doing that so far, another thing we can do when we've got a right angle triangle is we can do some Pythagoras. So I know the hypotenuse is 8 meters. I want to find out what the height is of that triangle, and because I've split the floor in half, I don't need 14 meters. In fact, I've only got 7. And so what I can do with that is I can use my Pythagoras formula. So I've got a squared plus b squared equals c squared. Chuck my numbers in. 7 squared plus something squared is 8 squared. Rearrange it so you get our unknown squared is equal to 8 squared minus 7 squared. Okay, depending on how good we're feeling about our calculator skills or our number skills, we need to work that number out first and then square root it. Or we can just type the square root of 8 squared minus 7 squared into our calculator and get 3.87 out as our answer. So this unknown height that we've got actually turns out to be 3.87. Okay, so the temptation is normally to stop there. We've done a whole load of work, but that's not it finished. Remember, it wanted the height of the tunnel. And so what we need to do to find the height is we need to add 8 to 3.87. So we need to add our two numbers there together. And when we do 8 plus 3.87, we get a total height of 11.87 meters.